It's got like a frilly tail and a little bit of an eye spot. And the mussel's able to push her gills up.
The Mississippi River was dying, not loudly, not anywhere a person could see it. On the surface, it still pushed 2,300 miles of freight and current along like nothing was wrong. But underneath, the system that had kept it clean for thousands of years was vanishing, one animal at a time. And no law, no ban, and no amount of money could stop it. Then the whole thing came down to 500,000 mussels, each one smaller than a grain of rice, with no brain, no eyes, and no way to move. How those animals changed everything is one of the strangest rescues ever attempted. The silent failure. Picture the Mississippi from a bridge, 2,300 miles of current, draining roughly 40% of the continental United States, shoving 500 million tons of freight past 29 locks and dams every year. The water moves, the barges run, the gates cycle on schedule. From up there, nothing looks wrong. But under the surface, the river was losing the one system that had kept it clean for millennia.
Plain pocketbook is one of the species that has male and female shell shapes. This is a younger pimpleback.
Freshwater mussels, dense living carpets of them, once paved hundreds of miles of riverbed, 51 species, packed so tightly that early surveyors said the bottom crunched underfoot like gravel, not scattered animals, a floor. Then it vanished. By 1999, at one of the most productive mussel beds in Wisconsin, density had collapsed from 149 animals per square meter to fewer than 2. In some reaches, field teams pulled up sample after sample and found nothing alive at all. The river still worked as infrastructure. As an ecosystem, it was dying, and almost no one upstairs could see it. The living filter. So, what were we actually losing? When the system worked, it ran like a city-scale water treatment plant on autopilot. No operator, no off switch. Each mussel pulled water in, passed it over internal gills lined with microscopic hairs, and pushed it back out clean. One adult filters 8 to 15 gallons a day. Now multiply that by millions, packed into beds stretching for miles. And the math stops being biological and turns geological. A healthy 6-mile stretch strips roughly 25 tons of suspended material out of the water every year. The mussels caught the algae and sediment, digested what they could, and dropped the rest onto the bottom as rich waste that fed insects, which fed fish, otters, and diving ducks. And because each animal buried itself partway in, their shells locked together like rebar and concrete, holding the riverbed in place against the floods. Filtration, food, and structure, all from an animal with no brain. It took centuries to build.
A part of their mantle, which is the part of the animal that builds their shell.
We took it apart in 3 blows. The button rush. The first blow was a button. In 1889, a German immigrant discovered that Mississippi mussel shells made excellent clothing buttons. Within a decade, flotillas of clam boats were dragging the bottom with hand dredges. 16 million pounds of shell came out of Wisconsin waters in 1899 alone. Beds that had taken centuries to form, stripped in a season. Remember, these animals live about 100 years. The harvest pulled them out faster than a century could replace them. And even after the industry collapsed and clamming was banned, they didn't come back, because by then, we'd re-engineered the river itself. The lock and dam system, built across the upper Mississippi in the mid-20th century, turned a free-flowing river into a staircase of still pools. That fragmented the migration routes of the exact fish the mussels need to breed, and slowed the current until clean gravel disappeared under oxygen-starved muck. The mussels were being remade for freight, but the worst blow hadn't even arrived yet. The living crust. It came from the other side of the world. Zebra mussels, introduced to the Great Lakes in 1988 in the ballast water of a transatlantic ship, rode the Mississippi south within years. They don't hunt native mussels, they just need something hard to grip. And in a river of soft mud, the only hard thing for miles is the shell of a native mussel already sitting there. So they pile on, thousands of them, encrusting a single animal, sealing its shell shut until it can't feed, breathe, or breed. It doesn't die fast. It dies slowly, entombed inside its own shell by a living crust it can't shake off. In the worst hit stretches, 80% of native mussels were gone within years. If a river quietly losing the animal that keeps it alive is the kind of thing that keeps you up, subscribe before the next part, because this is where one specific mussel walks up to the edge of extinction, and a handful of people decide to drag it back by hand. At the center of it sat the Higgins eye pearly mussel, a yellow-brown thing no bigger than your hand, easily mistaken for a mud-caked rock. Once spread across 850 kilometers of the Mississippi and 9 major tributaries, its range shrank by more than half. By 1999, sampling at sites once crawling with them turned up 0 living specimens. The locked circle. And you couldn't just breed more, because the Higgins eye reproduces through a trick so elaborate it sounds invented, and the river could no longer support a single step of it. The water was too cloudy for fish to find the mussel. The dams had broken the fish routes. Any juvenile that did reach the bottom got smothered or crusted over before it grew strong enough to fight back. So, follow the logic with me. The mussels needed clear water to breed, but the water couldn't clear without the mussels. No law, no harvest ban, no fenced-off habitat could break that. You could protect the animal perfectly and still watch it spiral to 0. Something had to reach in from outside. Building by hand. In 2000, a coalition of federal biologists, hatchery techs, and state agencies formed with one blunt mandate: build the reproductive pipeline by hand. If the river couldn't run the mussel's life cycle, they would run every stage of it themselves and put the finished animal back. It starts with the mother. They find egg-carrying females in the last surviving pockets, slide a blunt syringe of river water into the gill pouches where the larvae overwinter, and flush out hundreds of thousands of them without hurting her. Each larva is under a millimeter, a translucent clamp. Then they hand her back to the river to breed again next year. In the wild, those larvae need a fish, and the way the mussel gets one is the strangest thing in this whole story. The female pushes out a flap of her own tissue and shapes it into a near-perfect fake minnow. Eye spots, coloring, a wounded little twitch in the current. She has no brain, no eyes, no idea what a minnow even is, and yet bass and walleye strike at it. And the instant they do, she detonates, blasting a cloud of larvae straight into the fish's mouth and across its gills. The metamorphosis. The hatchery skips the magic trick entirely. Techs drop bass and walleye into tanks and pour in a slurry of larvae, up to 4,000 per liter. The fish breathes. The larvae clamp onto its gills. Within minutes, thousands of microscopic parasites are locked on. Then, the real transformation. Each larva triggers the fish's immune system, and the fish's own tissue grows over it, sealing it in a tiny pocket. Inside, feeding on the host's blood, the larva rebuilds itself into a complete juvenile mussel. Foot, shell, feeding parts. The whole thing runs on a heat clock. Every degree above a baseline adds to a running total, day after day, and at roughly 350 to 400 accumulated heat units. The pocket ruptures and the juvenile drops. In a tank, it lands on a tray. In the river, it lands on the bottom and almost certainly dies. And that is the wall biology couldn't climb. The concrete dome. Which brings us back to Chris Barnhart and his concrete shape. The fix is a mussel silo, a dome about 12 kilograms, 30 centimeters across, with a PVC chamber inside capped at both ends with fine mesh. You load the juveniles in, lower it to the riverbed, and walk away. Watch what the water does. As current flows over the curved top, it speeds up, the same physics that lifts an airplane wing, and that creates a low-pressure zone over the opening that pulls water up through the chamber from below. The river becomes the pump. No electricity, no moving parts, just a curve and a current. It feeds the juveniles oxygen and food, hides them from predators, keeps sediment from burying them, and keeps zebra mussels off shells far too small to survive being crusted. The numbers were brutal in the best way. Direct release into the river. Survival in the single digits. Inside the silos, 81 to 92%. Same animal, same river, same year. Separated by nothing but a dome. Barnhart had a machine that worked. What nobody knew was whether the river would ever run it without him. The long silence. So they ran it for the river. The Genoa National Fish Hatchery in Wisconsin started pushing out over 500,000 juveniles a year, each one under a millimeter, each one the end product of a wild mother, a syringe, a host fish, a parasite, a metamorphosis, and a concrete dome. They lowered them into the mud, then they waited, and nothing happened, not visibly. Mussels grow millimeters a season and live 50 to 100 years. From a barge, the water still ran brown. For years, the only proof the project hadn't failed was that nothing had obviously died. Picture the recovery at its lowest point: 75 people, one Wednesday a year, going down to the Cordova bed, one of the last places adult Higgins' eyes still clung on, pulling animals out of the mud one at a time, and scrubbing the zebra mussels off their shells by hand. That was the front line. Meanwhile, under the silt, the deployed juveniles were quietly crossing a size where their shells could anchor, lock the riverbed, and feed a food web back to life. Nobody could see it yet. The proof. Then, in 2005, a biologist kneels over a tray of bottom sediment hauled up from Pool 10 at Prairie du Chien, the exact site where, 6 years earlier, sampling had turned up nothing alive. Fingers move through the muck, and there they are, tiny juvenile mussels. Untagged, no hatchery mark, no silo. Stop and feel what that does to the person holding them. These weren't placed here, they were born here, lured onto a wild fish's gills, transformed inside a cyst, dropped, and survived, with no syringe and no one watching the temperature. The pipeline the team had been running by hand for 5 years had just completed on its own, in the dark, in the current. At Cordova's Pool 14, the agencies made it official, reproducing and self-sustaining. The loop had taught itself to turn, and that cracked open a far bigger question than one rescued species: the wider win. Because these animals don't just clear sediment, they pull excess nitrogen out of the water and turn it into harmless gas. They lock heavy metals inside their shells. They strip bacteria that downstream towns would otherwise spend millions removing with chemicals and filtration plants. Every gallon a mussel cleans is a gallon a treatment plant never has to. And as the beds thickened, the water cleared. Light reached the bottom for the first time in years, and where it landed, wild celery came back. Underwater meadows spreading across reaches that had been too dark for decades, pulling in diving ducks and cover for native fish. That clarity feeds a loop. Clearer water lets bass and walleyes see the females twitching lure. More strikes mean more larvae. More larvae mean more adults. More adults mean clearer water. By cleaning the river, the mussels engineer the exact conditions their own breeding needs, and the cleaner it gets, the less we have to help. The whole rebuild costs less than $1 million in state funding, against the tens of millions a year it would take to do the same work with machines that burn power, while every one of these runs for free for up to a century. 500,000 brainless, eyeless animals that can barely move, quietly pulling the Mississippi clean, doing now exactly what their ancestors did for millennia before the button boats and the dams and the zebra mussels ever showed up. So here's my honest question for you. What's another broken piece of an ecosystem you think we could rebuild by hand, if we were just stubborn enough to try? Drop it in the comments, and if this is the kind of story you want more of, subscribe. There's plenty more down here.